Okay, my friends, let's take a look at this homework and get some answers for some of these questions. Think back to the video where you looked at a data set that display. Oh yeah, that's this one here. That's this data set right here. Make that bigger for us to look at. That's a little better. So 1975 through 2018, an overarching trend downward in teenage motor vehicle crash deaths from 75 to 2018. Okay, so I just asked you to come up with a source that you would think could explain that. Why would teenage motor vehicle crash deaths be going down over time? And some of you came up with some really, really good answers. Again, there's not one right answer, most likely. It's probably many, many answers that are all interrelated. One could be just better driver's education, more defensive driving training. That could be as simple as that. It could be the fact that in 1975, cars weren't built to withstand crashes in such a way to protect the driver. Now cars have crumple zones. Later cars that were made here have crumple zones that absorb the force from accidents. If you've ever driven in a car from the 1970s or 1980s, they're big steel boxes. And a lot of times that just transferred the forces right into the car. Nowadays, a lot of areas on cars crumple under impact, which means you would protect the passengers and driver. So there's many, many reasons. I wasn't looking for any one particular reason, just an explanation, some kind of explanatory reason as to why they're going down. Now, the next bit is all based on this troublesome spreadsheet that Mac users had a hard time using, running, but I gave you all the screen captures you would need. So I'm going to use a spreadsheet. Which of the following three data sets is most strongly positively correlated with course average out of 100? Okay, so course average out of 100, I want to make that one this one here. And the reason I picked that one is because I wanted you to look at the data and see the most important data set is how y'all do in this course. Your end average out of 100% in Math 105. Which of these predictor variables influence that the most? Let's take a look. I wanted you to sort through exam average, hours spent outside of class, and number of mandatory courses missed. Okay, so let's do that. Exam average is going to be up here. Whoops, that's project 4. Exam average, boom. Okay, well that's positively correlated, and it's a pretty tight cluster too. The worse you do on that exam average, the worse you do in the course on average. Now there are some people, like for example in this 60 through 80, that aren't doing fantastically well in the course. And there are some people that have very close to 100 exam average, but are still only sitting at the 90s. But you see how there's a trend upward? It's trending upward. That's exactly what a positive correlation should look like. Okay, cool. I forgot the other two now. Hours spent outside of class. This was a fun one I collected a couple terms ago. Oh, no, not much of a correlation there. If anything, it's trending downward, which is interesting, but I would call that not really a correlation at all. So far, exam average looks the best, and the last one was number of mandatory quizzes missed. Oh, and that's most definitely a negative correlation. Yeah, which makes sense. The more quizzes you miss, the worse you should do in the class. I mean, honestly, if you're using quizzes to assess your knowledge of the topics. All right, cool. So I think exam average, I think that was the one that most highly positively correlates. All right, and I think the next one here, which of the following 5 data sets, project 1, 2, 3, 4, or the average of the projects? Okay, well, let's go through this. Here's project 1. Slightly tilted up, but I would say not terribly strongly correlated. Yeah, same kind of thing. Maybe a little tighter than project 1, but not very. Okay, that's the best of the batch. Let's look at the average and see if the average smooths. Okay, there you go. Project average actually smooths them out. This is one of those examples. The reason I picked this one was when you look too closely at a data set, you get lots and lots and lots of variations sometimes. When if you just back up and look at how that one data set implies a general behavior of the entire data set, like for example, project 2 versus the average of all 4 projects. that's a much better overriding view. So it looks like project average does a really good job of correlating positively with overall course average. Okay, good. What's the next question? Find a data set that doesn't appear to be correlated at all. As a matter of fact, we already saw one. We saw one. It was hours spent outside of class. That was a good one. Hours spent outside. Oh, not course average. Excuse me, wrong one. There. That one doesn't seem to be correlated at all. I'm sure there's some other ones, but that was the one that we saw earlier. Save ourselves some time and just use that one. You may have noticed a little drop-down menu at the bottom left. Oh yeah, this is the extra credit one. This is probably the reason you folks with Macintoshes couldn't use my spreadsheet. I'm going to change that to bubble. This is not a very good one, but I'm going to find one that is. It's probably going to be within the projects. Yeah, like here's a good one. Project number 4. You might notice that if we change bubble to scatter and then back to bubble, it's a little hard to see because the axes shift. But the points are in the same place. Like if you look at these points right here, these points are in the exact same place. They're laying on top. You see this little cluster right here? 1, 2, 3, 4, 5. It's like about six points. There they are right there. Maybe more than 6, but they're right there. They're in the same spot. What a bubble chart does is it counts the data points that occur more than one time. For example, that bubble right there, which I'm having a hard time clicking on. I can click on it over here, though. I bet. This one right there. That particular point right there. Let's see if I can get Excel to tell me what it is. There. It says size 3. The data point is 23, 103, and its size is 3. What that means is there are 3 students who had a, I'm having a hard time with it, had a 23 on project number 4 and ended the course with 103% average. 3 students had that. So that circle right there has a diameter that's 3 times as big as the other circles. So what I'm having the Excel chart do is if you look up at this, which is the scatter plot, and you look at 23, 103, it's going to be, I think, I'm going to have a hard time finding this one. It might be that one right there. I think that was it, actually, right? Yeah, 23, 103. But do you see how that point is as big as this point? And there's only one student that had a project 4 grade of 7 and a course average of 101. So what I do with the bubble chart is I show you how many students had a certain arrangement of values of project number 4 grade and final course grade. This one here, there's 2. There are 2 students that had a final average of 17 and a course average of 98%. Where I'm doing the math, if you're interested, is right here. Here are all the X and Y values, depending on what you choose back here. As you might notice, you might not actually. If you choose different values here, then these columns change over here. And you notice the bubble chart and the scatter plot change too. Up here, the bubble sizes count how many students have this arrangement. So you'll notice right now, there are 2 students that have a 25.75 project average and 107 in the course. Now, what's tricky is finding the other student. There's one of them. This student in row 8 has, here, let's go look at the student. There's row 8 right there. Here's all the assessments for that student. There's all the assessment for that student. They have a 25.75 project average and 107 in the course. Where is the other student who also has this? Let's go find them. Where? I missed it. See, it's hard to find. This is why I have Excel count it for me. 25.75. I'm looking for it, and 107 in the course. There it is, right there. It's right above. I went the wrong way. Oh no, that's row 8. It's right here. There's the other student. So they're in row 17. So row 8 and row 17 are 2 different students, but they happen to have the same project average and the same overall average in the course. Most other things in their rows are different. For example, student 8 spent 2 hours outside of class. Student, what was the other one? Student 19 spent 3. That's different. Excuse me, 4. There they are. See, it's very hard to keep track of this. This is why I have Excel count it for me. They both have 107 average. The quiz average of row 8 was 10. The quiz average of row 7 was about 9.9. 11 quizzes done out of 10 needed, 13 quizzes done. You see how they're different? 14 warm-ups versus 16 warm-ups. They're different students, but they happen to have the same project average, and they happen to have the same final grade. So what the bubbles are just showing you, is quite simply, is how many students have that particular arrangement. Apologies to Mac users, because this feature caused great consternation in your computers, but it does give you a third dimension, so to speak, of what's going on that you don't get otherwise when you just look at a scatter plot. Okay, I hope that helped. We'll talk to you soon.